Hey guys, today we're going to go back to working on reflecting, but we're going to do it in a slightly different way. There are going to be times where you guys are going to have to do transformations without planes. So we need to be able to go back and forth between the two and know exactly which way we're going and how things are going to change. So when reflecting without a plane, when you're reflecting over the y-axis, the x value is going to change. And by that I mean the x value is going to go from negative to positive, or positive to negative depending on what it is. So let's say I have a coordinate of -1 and 7. Okay? That means I'm 1 space away from the y-axis. To reflect over the y-axis, the x value changes by becoming +1 and 7. And I'll prove this to you on a plane here in a second. And the opposite happens when you reflect over the x-axis. The y value changes. Let me show you. Alright, so here I have triangle JKH. And we're just going to, for this purposes, we're just going to reflect point J. And point J is located at 4, 4. Now, if I want to reflect over the y-axis, which is again my up and down axis, I know that my x value is going to go from positive to negative. So I'm going to go ahead and write that out, and then I'm going to prove it to you. So this is going to be my new coordinates after I reflected over the y-axis. So I see I'm 4 spaces away, so I'm going to count to the y-axis. 1, 2, 3, 4. And then I'm going to go 4 spaces more. 1, 2, 3, 4. Drop off my point at -4, 4. And this becomes J prime. Now, what if I wanted to go over the x-axis? Well, if my original point of J is located at 4, 4, and I'm reflecting over the x-axis, that means my y value is going to go from positive to negative. So my new coordinates are going to be 4, -4. Let me prove it to you this time. Alright, I'm 4 spaces away from the x-axis. I'm going to go 1, 2, 3, 4. And then I'm going to go 4 spaces more. 1, 2, 3, 4. Drop off my new point at 4, -4, which is exactly what I had said. Let's do another example without a plane. Alright, triangle ABC has vertices of 3, 3, 6, 3, and 3, -1 respectively. What are the new coordinates of A prime after the triangle is reflected over the x-axis? Well, A is 3, 3. So, we'll stay organized here. This will be us reflecting over the x-axis. And this will be us reflecting over the y-axis. And this is our original coordinates. If I'm reflecting over the x-axis, I know that my y value is going to be the one that's going to change. It's always the opposite. So, if I reflect, my x value stays the same, and my y value just goes to negative. So my new points would be 3, -3. And if it helps, think about it in terms of drawing your own small little plane. If this point is at 3, -3, and I know I'm going over the x-axis, I know I'm going from a positive x and a positive y to a positive y and a positive x and a negative y quadrant. So that's another way for you to think about it. Let's do the y-axis. If I'm reflecting over the y-axis, I know my x value is going to be the one to change. So my new coordinate will be -3, 3. And again, think about it in terms of the plane. If my original point is in this quadrant, which is a positive y and a positive x, and it's being reflected over the y-axis, it's going to quadrant 2, which has negative x values and positive y values. So, just keep in mind it's always the opposite. Let's do another one. Line segment AB is located at -5, 7 and -1, 3. What are the new coordinates after a reflection over the y-axis and a dilation of 3? Alright, first thing I'm going to do is I'm going to draw a line. And this is going to separate, this will be our reflection, and this will be our dilation. Okay? I'm going to do each one of these individually. First thing I need to do is figure out the new coordinates after we reflect over the y-axis. All right? So our original coordinates are at -5, 7, and -1, 3. If I'm reflecting over the y-axis, that means that my x values are going to be the ones that change. So that means that my new coordinates are going to be 5, 7, and 1, and 3. Because again, my x values are the ones that are changing. Again, if you need to think about it in terms of a coordinate plane, -5 and 7 is going to be in this quadrant, okay, where there are negative x values and positive y values. Likewise, when I reflect over the y-axis, that point goes in this quadrant, quadrant 1, where there's positive y values and positive x values. Now, let's dilate these. Let's assume I'm dilating about the origin, which means I'm multiplying these values by 3. So my new coordinates, 5 times 3 is 15, and 7 times 3 is 21. So my new coordinates for A, this will be A double prime, will be 15 and 21. Likewise, 1 times 3 is 3, and 3 times 3 is 9. So these are my new coordinates of my super duper long line segment. Alright guys, that's going to be it for me today. Let's go ahead and try and practice this.